We live inside the Milky Way galaxy, but in many ways, we barely know it. You might think we've figured it all out, where the stars are, what shape it is, how many spiral arms it has. But the truth is, even the basics of our own galaxy remain a mystery. How many stars does the Milky Way contain? Depending on which estimates you trust, the number ranges wildly between 100 billion and 400 billion. And the shape of the galaxy? We used to think it had 2 spiral arms, now it seems it may have 4. These aren't minor details. They speak to how little we understand the very galaxy we call home. It's hard to study something you're inside of. You can stare out your window and see the house across the street. But try getting a full view of your own house from that same window. That's what it's like trying to observe the Milky Way from within. And yet, there's something even more startling. How many galaxies exist within the Milky Way? That might sound like a strange question. Isn't the Milky Way a single galaxy? According to data from the Gaia Space Telescope, which spent 10 years mapping the stars in our galaxy, the answer isn't just one. Because 30,000 stars in our galaxy are moving in ways that don't make sense. They're going the wrong direction, and that's because they're not originally from around here. Let's dive into the Gaia data and uncover how many galaxies the Milky Way has consumed over its lifetime. Observing our galaxy is challenging. Stars, gas clouds, and interstellar dust clutter our view, especially toward the galactic center. Astronomers even have a name for this opaque region, the zone of avoidance. Visible light struggles to get through it, so scientists turn to X-rays, infrared, and other wavelengths to peer deeper. It's like sitting in your bedroom and trying to figure out the layout of the whole house, when thick walls block your view of every other room. Add to that another problem, figuring out how far away stars are. To map a galaxy in 3D, you need to know whether a star is close and dim, or distant and bright. Some types of stars, like variable stars, are consistent enough in brightness that we can estimate their distance. But most stars aren't that predictable. That's where parallax comes in. Parallax is the idea that your perspective changes as you move. Hold a finger in front of your face, close one eye, then switch. The finger appears to move. The closer it is, the more it shifts. That's parallax. And Gaia used this principle over a decade, capturing star positions as Earth orbited the Sun. This orbit creates a natural base, like using the entire solar system instead of just your eyes. Over time, Gaia created the most detailed 3D map of our galaxy ever, observing nearly 2 billion stars, tracking their motion, brightness, temperature, chemical makeup, and more. And by observing how stars moved over time, scientists could even rewind their motion, like watching a cosmic security tape in reverse. And when they did, they discovered something astonishing: a galaxy collision. About 30,000 stars in the Gaia dataset were found to be moving opposite the flow of the rest of the Milky Way. Their composition was also different. That led scientists to conclude they were remnants of a smaller galaxy, the Gaia Enceladus galaxy, that merged with the Milky Way around 8 to 11 billion years ago. This wasn't just a cosmic bump in the night. The collision likely shaped some of the Milky Way's unique features, including its central bar, a structure only about 2/3 of spiral galaxies have. But Gaia Enceladus wasn't the Milky Way's only midnight snack. Scientists have found evidence of up to 6 different dwarf galaxies being absorbed by the Milky Way over time. One of the most significant ongoing mergers involves the Sagittarius dwarf galaxy, which has already collided with the Milky Way 3 times in the past 5 billion years, and is on course to do so again. These collisions may have triggered star formation events, possibly even the birth of our own sun. Each of these galactic meals left behind a stellar fingerprint, stars moving at odd angles, chemical signatures, or entire structures like stellar streams wrapping around our galaxy. The Gaia mission wrapped up its observations in January 2025, after a decade of operations, running on cold gas propellant, just 12 grams a day. But even though Gaia's eyes have closed, its legacy is far from over. 2 more data releases are on the way. One, in 2026, will include half a petabyte of data, revealing possible exoplanet locations and the largest binary star catalog ever assembled. And by the end of the decade, Gaia's final data release will provide a full 10.5 years of the most detailed galactic mapping humanity has ever achieved. But Gaia's view was limited to visible light. many parts of the galaxy remain hidden behind thick curtains of dust, until now. That's where VISTA comes in. The European Southern Observatory's VISTA telescope captured the most detailed infrared map of the Milky Way to date. From 2010 to 2023, it observed for 140 nights, collecting 200,000 images and 500 terabytes of data, roughly equivalent to streaming 4K video continuously for 3 years. Using infrared wavelengths, VISTA could peer through the dust that blinds visible telescopes, revealing star clusters and structures never before seen. With its powerful camera, VISTA detected brown dwarfs, failed stars, and young stars buried deep within nebulae. For example, the Trifid Nebula, when viewed in visible light, is a beautiful pink and blue cloud. But when viewed with VISTA, a whole new swarm of stars emerges from behind the haze, including 2 variable stars located far beyond the nebula, previously invisible to Earth. These types of stars, known as Cepheid variables, pulsate in predictable cycles, and because of that, they act as cosmic yardsticks, allowing astronomers to calculate distances across the galaxy. By mapping these Cepheids, scientists discovered something incredible: a thin disk of young stars stretching across the galactic bulge, hidden until now. This challenged previous beliefs that the bulge contained only ancient stars. Instead, there's been continuous star formation there for at least the past 100 million years. And VISTA didn't stop there. In 2016, it identified a rare type of ancient star, an RR Lyrae variable, near the galaxy's center. These stars are usually found in globular clusters, massive balls of old stars orbiting the galaxy's outskirts. Finding them in the center suggests that the bulge might have formed through ancient mergers of globular clusters, rather than just slow accumulation of gas. VISTA even found 2 new globular clusters, faint, distant, and previously hidden behind dust. One of them, VVV-CL00002, may be the closest globular cluster to the galactic center. And that's not all. The survey uncovered nearly 100 new open star clusters, smaller, younger groups of stars scattered throughout the galaxy, each one a potential nursery for future discoveries. One of them, VV-CL00003, sits 15,000 light-years beyond the center of the Milky Way, making it the first open cluster discovered on the far side of the galaxy. These revelations are rewriting our understanding of the Milky Way's formation and structure, and thanks to Gaia and VISTA, we now have the most complete 3D map of our galaxy ever created. But wait, there's more. Despite the Milky Way's relatively quiet appearance today, it may be hiding dozens of miniature versions of quasars, some of the brightest objects in the universe, within its own borders. Known as microquasars, these are formed when black holes just a few times the mass of the Sun begin devouring material from a companion star. One of the first, SS-433, showed jets of energy being emitted at a quarter the speed of light. And thanks to advanced observations, scientists now believe that electrons in these jets can be accelerated to nearly the speed of light through a process called diffusive shock acceleration, like particles hitting boost pads in space. And while these microquasars are too faint to be dangerous like full-sized quasars, they're close enough to be studied in exquisite detail, giving us insights into the engines that power galaxies across the universe. As astronomers continue to sift through Gaia and VISTA's treasure troves of data, there's no doubt we'll uncover even more hidden galaxies, unknown star clusters, and ancient celestial collisions. So the next time you gaze up at the night sky, remember, there's far more to the Milky Way than meets the eye. It's a galaxy built on collisions, wrapped in mystery, and brimming with secrets waiting to be revealed.